Let's get started, please. All right, so picking up from where we were last day, I mentioned that there are no pointers in Java, right? So you don't have to, as a programmer in Java, you don't have to deal with pointers. However, the fact that you hopefully know what a pointer is will make things a little bit easier to understand how things work in Java. Right? And so I guess this is a good place for a sidebar. Did they ever tell you why C uses pointers? Did anybody ever explain to you why the language uses the pointers? Anybody? Anybody? Yes? No? No? That's not great? Okay. So, all right. So look, here's a little C program. Right? Now I'm pretty sure if you took your Elect 278, you would have learned what a struct is. Right? So there I've got a structure. Right? Inside the structure, it's just got an array. Right? Now this array happens to be very large. Right? It's an array of ints, and there's 1 million ints in this array. Right? I've got a function here. Right? That function takes in a structure as its argument. Right? Here's my main function. Right? If I call that first function, go away. If I call that first function here, right? What happens when you call my function is that the contents of S, right, which includes this array of 1 million elements, all of that stuff has to get copied and passed up to this function here. Right? So C uses a mechanism called pass by value. Pass by value means it takes the value of S. S is a structure, so its value is the value of everything inside of it, which is this array of size 1 million. Right? Pass by value means it makes a copy of that and passes the copy to the function. So it's got to copy 1 million ints to call this particular call this particular function. That takes a lot of time, right? It also takes up a lot of memory, right? This doesn't have to be 1 million. It could be 1 billion. It could be much bigger, right? And that takes up, right, lots of time, lots of memory. If instead you pass a pointer to the structure, right, all that happens is, right, so if I call the second version of the function, passing in the address of my structure S, all it has to do is copy the pointer, right? The pointer is just 64 bits on my computer, right? And so it just has to copy that 64-bit number and pass it up to here, right? And that's a lot more efficient than copying 1 million ints and passing that up to here. So that's just one of the many reasons why pointers are useful in the C programming language. Right? It's because the language uses this mechanism called pass by value. There are other reasons as well. Right? All right, so Java has no pointers, but it's useful to know what a pointer is in order to understand what a reference is in Java. Okay? So Java has 2 basic kinds of types. There's primitive types, and there's reference types. Right? A primitive type is something like an int or a double in Java, right? So an int or a double in Java, the value that's stored in memory with the variable is just the value of the int or the value of the double, right? So if you have the int 1, the value 1 gets stored in memory. The value 1 is associated with the variable in memory, right? Any type that begins with a capital letter, right? So something like string, right? Or something like list, which I'll show you in a little bit, or array list, anything that begins with a capital letter. Right? Any of those types, those are called reference types. Right? So whenever you make a class, you are making a reference type. Right? So classes are just user-defined reference types. Right? And that's why the Java programmers use this convention. When you make a class, name it with an uppercase letter. That way everybody knows it's a reference type object. Right? The primitive types, they are all lowercase. Right? Int is lowercase I, N, T. Right? Doubled is lowercase d, O, U, B, L, E, right? So those are all any type that begins with the lowercase, a Java programmer will automatically assume that it's a primitive type value, right? Unless you happen to be a jerk and you name your class with the lowercase letter, and then you confuse everybody that's reading your program, right? So don't be a jerk. Right? Okay, so your primitive types in Java are the following, right? So Boolean, that's true, false, right? These are all integers, byte, char, short, int, long. Right? And float and double are your floating point types. Right? So these are all, with the exception of Boolean, these are all the same as in, more or less the same as in C. All right, so what about these reference types? Right? So a reference variable, right? In memory, what gets stored is what's called a reference to an object, right? So I told you strings are this string s, well, it's the string hello, right? There's an object somewhere in memory that represents this string hello, right? Inside that object, there's probably an array of characters, right? H, E, L, L, and O, right? There's other stuff in that object as well. I don't know what's in there. I've never looked at the source code for string, right? So in this particular case here, s, right, the variable s does not store the object that represents hello, right? So the object that represents hello is not stored with s. Instead, what's stored with s is a reference to the object that represents hello, right? And a reference is just some value that lets the Java virtual machine find an object in memory, right? And that sounds an awful lot like a C pointer. And in fact, that's often how it's implemented inside the Java virtual machine, right? So a reference is often just a pointer, right? So S you can think of, because you've learned C, right? S is just a pointer to some object that represents the string hello, right? So even though I told you there are no pointers in Java, there are these things called references. References happen to behave a lot like pointers, with the exception that you can't do arithmetic with them. You can't actually get the address of the object directly from them, and so on and so on and so forth, right? But they work similarly to the way the pointers work, right? So here, S refers to the string hello, right? So it's the address of some object that represents the string hello, right? I can reassign S so that it refers to some other object, right? So if I now write S equals, or is assigned the value, the string goodbye, right? There's now a string object that represents goodbye, and S holds the address of that new string object, right? Hello is still somewhere in memory, right? So somewhere there's still a string object that represents hello, right? Here there's now a second string object that represents the string goodbye, right? S is not the string hello, right? It's a reference to the string hello. And S here is not the string goodbye, it's a reference to the string goodbye, right? So the easiest way for, I think, for most of you to think about this is that it's just a pointer, right? Now the difference between reference types and primitive types is that with a primitive type, right, so int x equals 1, right, x really does store the value 1, right? So if you were to imagine a picture of memory, there would be some box labeled x, and beside that box there's the number 1, right? Here there's some box labeled y, and there's a number 1.0 beside that box, right? So primitive types store the actual value, reference types store references to objects. So for the primitive types, all the primitive types occupy some defined fixed amount of memory, right? Which you can, if you really want to know what they are, right, they're all in this table here. Right? Different primitive types occupy different amounts of memory. This turns out to have all sorts of weird implications. Right? Okay, so if you want to do something involving integers, normally you just use int, right? If you happen to know that your integer values are going to be very large, you might use long. If you happen to know that the values are going to be bigger than what a long can hold, you have to do something else, right? But that's a topic for another day. Okay, so there's a minimum, so there's an int occupies a finite amount of memory. So there's some smallest int, there's some largest int, right? The smallest integer value that you can represent is in the constant big I integer dot, all caps min value. If you ever see anything in all caps, it probably means it's a constant in Java, right? So big I integer dot min value is the constant corresponding to the most negative integer int value that you can store in an int variable. So that's minus 2 billion roughly, right? Similarly, there's a maximum value, that's an integer dot max value, right? And that's roughly 2 billion. Notice it's not symmetric, right? That ends with an 8, that ends with a 7. Okay, so an int literal works the same way in Java and in C. If you just write down some number with no decimal in it, both in Java and C, that's considered to be an int literal, right? So 99, that's an int literal, right? Minus 1, int literal. If you need a long literal, you write down the number. You write down the number, and then you write uppercase L or lowercase l beside it, right? So 9 big L would be a long literal, right? Works exactly the same way as in C. Unlike C, in Java, if you try to store a value, if you try to write down a literal that's larger than that or smaller than that, right? That results in a compiler error, right? So your Java compiler won't compile it, right? The arithmetic operators work exactly the same way in Java as in C, right? So plus, minus, divide, remainder, so the percent sign, right? No exponentiation. I don't remember if C lets you use underscores in a literal, but in Java you can. So if you have a long literal and you want to make it easier to read, you can insert underscores into the literal, right? And if you happen to know what binary, octal, and hexadecimal are, there are ways to write down these numbers as well. I don't care about them for the purposes of this course. Okay, so if you do arithmetic in C or in Java, and the arithmetic involves 2 int values, so I add 2 int, subtract 2 ints, divide 2 ints, right? Oh, where is it? Sorry, I must have skipped over some slides. Here it is, sorry, right? So any arithmetic operation involving 2 ints always produces another int, right? So if I take 1 divided by 2, the result is an int, right? Works exactly the same way as in C, right? So here I've got 1, 3, and 13. If I add x and y, 1 and 3, I get 4. Right? If I divide x and y, right, it's 1 divided by 3, right? And so you end up, that does integer division, right, in both languages. So integer division is like regular division, you throw away everything after the decimal point, right? So 1 divided by 3 is 0.33333. Throw away the 0.33333, you get 0, right? 13 divided by 3 is 4.33333. Is that right? Sorry, 4.66666, right? Throw away the 0.66666 and you get 4, right? And of course you get parentheses as well, and parentheses let you control the precedence, right? The order of operations, right? So it works the same way in both languages, right? If you have 2 ints, it always performs int arithmetic, right? Even with division. Now, what happens? There's a minimum and a maximum value. So if I perform some sort of arithmetic with 2 int values, and the result does not lie within the range integer min value and integer max value, something has to happen, right? And so if you perform an arithmetic operation and that produces a result greater than integer max value, all that happens is that it wraps around to the smallest value, right? So if I start at integer max value and add 1 to that, right? I can't represent that number in int, right? But here, x is an int, 1's an int. Java compiler says, all right, we're doing int arithmetic. That's integer max value plus 1. Can't represent that value, so it wraps around and goes to integer min value, right? So you're now in the situation where you have a positive number and a positive number. You add them together, you get a negative number, right? Doesn't make sense mathematically. That's the way it works in programming. Right? It works this way in C, C++, C#, Java. So all the C-like languages work this way, right? If I start out with integer max value and add 2, right, that wraps around, and then you add 1. So that gives you integer min value plus 1, right? If I start at max value and add 3, it wraps around, so plus 1, plus 2, plus 3, you get integer min value plus 2. Right? The same is true in multiplication. If you multiply 2 numbers and it goes past max value, it just wraps around and keeps on going. Similarly, if you have 2 values and you do some arithmetic with them and it goes below integer min value, it wraps around to the other side. Right? So if you start out at the smallest integer value and subtract 1, that wraps around and goes to integer max value. Right? So negative value, subtract another value, subtract a positive value, you end up with a positive value, right? Doesn't make sense mathematically. That's how it works on your computer, right? X minus 2 is integer max value minus 1, right? And x minus 3 is integer max value minus 2, and so on and so on and so forth, right? So this thing here is called integer overflow. I don't know if they teach you that. Do they teach you this in your previous courses? No? This is called integer overflow. This is the way it works in all the C-like languages, right? So integer overflow occurs when an arithmetic calculation with an integer type results in a value that is outside the range that can be represented by that type, right? In Java, wrapping occurs. In C, wrapping occurs, right? Other languages handle this in different ways, right? In Python, this doesn't happen, right? In Python, Python has no limits on the range of values that can be represented with an integer. So it just keeps on going, right? Other languages that are designed for safety critical applications, they may do something else, right? They probably don't wrap around. They probably signal some kind of error of some kind, right? You might think this is crazy, but this is the way it works, and it's caused all sorts of problems, right? And here's a list of stuff that you might want to look at in your free time. I'll look at a few of these. So Ariane 5 is the European Space Agency's current rocket. So in its maiden flight, V88, so this is the first flight. It was carrying a bunch of satellites worth hundreds of millions of dollars. The rocket fell out of the air, right? Caused, it was very embarrassing to the European Space Agency, cost them all sorts of money. Why did it happen? Guess what? Inadequate protection against integer overflow. So what happened here was that they took the software for the previous rocket, Ariane 4, which was a lot smaller, right? The software that was designed for Ariane 4 assumed that certain values certain integer values would fit in a certain number of bits. Ariane 5 is a lot bigger, so those corresponding integer values no longer fit in that number of bits. You end up with integer overflow. That caused the inertial navigation system to shut down. Rocket fell out of the air. I forget how much money it cost. It was hundreds. Oh, here it is. $370 million down the drain, right? All because of integer overflow. GPS, which everybody uses, right? It's on your phones, it's everywhere now. Every 1,024 weeks, it rolls over. There's an integer rollover, right? So in the way GPS works is that it broadcasts the time. One of the pieces of information it broadcasts is the week number. Its week counter goes up to 1,024, right? Starts at 0. So when it hits 1,023, you go to the next week, it rolls over, goes back to 0. So roughly every 20 weeks, you end up with the wrong week if your GPS software doesn't account for it, right? And slightly before your time was the year 2000 problem. Anybody hear of the year 2000 problem? Yes? Okay. Some of you have heard of it. I bet you not all of you have heard of it. So the year 2000 problem occurs because prior to the year 2000, a lot of software stored the year of a date using only the last 2 digits of the year, right? So 1995 would be stored as 95, right? That's a problem when you hit the year 2000 because now you've got 00. And the software now has to decide, is this the year 1900 or is it the year 2000? Most software decided it was the year 1900, right? This is a huge problem, right? If you're working for a bank, right, suddenly you're now paying an extra 100 years of interest, or you're charging an extra 100 years of interest when it rolls around to the year 2000, right? If you're maintaining some database of people's ages, right, suddenly someone is either 100 years older or 100 years less in age than they should be, right? This caused all sorts of problems. You might wonder why computers were storing dates, or people were storing dates using only the last 2 digits in the year, right? And the reason is because memory used to be very expensive, right? So if you read this article, it actually goes into a lot of the details here. But back in the early days of computing, when people first started using computers for business applications, memory was like $1 per bit, right? So $1 per bit. So think about that. Your cell phone probably has 8 gigabytes of memory, right? So 64 billion bits, right? If we were still paying $1 a bit, your cell phone would cost $64 billion just for its memory, right? So back in the day, memory was very expensive. It was also very slow. And so anybody writing an application that had to store a whole bunch of dates would try to save as much memory as possible. So they would only store the last 2 digits of the date, right? And this just carried on, right? People who wrote software in the 1970s thought, well, this software is only going to be used for 3 years. It's not going to be a problem. Lo and behold, 30 years later, their software is still being used, and now there's all sorts of problems. people made their careers helping companies solve this problem. So there was somebody in the computing science department who formed a company to help banks and other companies solve this problem. If you scroll down somewhere it tells you how much money was spent trying to fix this problem. Somewhere, sorry, here. Oops, sorry, here, cost. Right. So no one actually knows the actual amount, but it's estimated that it was something like $300 billion spent worldwide trying to address this problem, right? Which is crazy. It's just a date, right? But this is all because the integer overflow occurs when you have when you're only using a finite amount of memory to store an integer value. Right? There's other problems as well. Therac 25 is a very sad story. Click on that link if you want to hear about it. It's a Canadian story too. It unfortunately killed some people. All right, so if you want to do floating point arithmetic, then your choice is normally double. Right? You can use float, but the default for most people is double. Right? Now, the way floating point numbers works is very different than the way integer values work. Right? So for floating point numbers, there is a largest value that you can represent. Right? So that's stored in double.max value. That's something like 10 to the 308. Right? So it's some enormous value. The most negative value is just the negative of max value. Right? So it's not double.min value. Double.min value is something else. Right? It's the smallest positive value. So it's the smallest value greater than 0 that you can represent. Right? We'll get into this a little bit later on in the course. Like int, if you do arithmetic with two double values, you always get a double value. Right? So here I've got 1, 3, and 13. This time, oh wait, I just missed a slide. Here we go. So a double literal is anything with a decimal point in it. Right? So 1.0 is a double literal. If you want a float literal, you put the f after it. Right? So 1.0f would be the float literal instead. Right? 2 dot is a double literal. Right? You can also use underscores inside your number if you want to. You have scientific notation if you want to use that as well. Right? If you don't know what scientific notation is, that e means times 10 to the power 6 in this case. Right? That number there has to be an integer. It can be negative. Right? So e, some integer, just means times 10 to that integer power. Right? So this is 1 point whatever. It's that number there written using scientific notation. Okay, so unlike the integer values, right, floating point calculations do not wrap around when they exceed the range of double. Right? So if you take two huge values and multiply them together, you don't get some negative value. Right? Instead, floating point values saturate. Right? So if you perform a calculation that goes outside the range of double, you either end up at positive infinity or negative infinity. Right? So if I take 10 to the power 200 multiplied by 10 to the power 200, 10 to the 400, that's bigger than double max value. Right? That ends up being positive infinity. Right? Similarly, if you take negative 10 to the 200 and multiply that by 10 to the 200, that's smaller than negative max value, so you end up at negative infinity instead. Right? So floating point values don't overflow, they saturate instead. All right, so that's all I want to say about the arithmetic types for now. We're going to get into more details on how you represent a floating point number on your computer a little bit later on. Okay, so C has functions. You all know this, right? So here's the function max, right? So normally in a non-trivial C program, right, you typically split your programs up into header files and source code files, right? Sorry, I'm going to close the door. Right? In the header files, you declare. Oh, that doesn't really help. All right, anyway, sorry. In your header files, you declare your functions, but you don't define them. Right? So that's a forward declaration in C or a prototype in C. Right? So this is the function max2. It computes the max of A and B and returns the maximum value. Right? Somewhere else, you define the function. Right? So maybe in max2.c, right? You define your function. Your function here is very weird, right? So if you want to compute the max of A and B, you could just write an if statement, right? I'm going to do this instead. It's strange, but it's here for a reason. Whoops, sorry. Right, so to compute the max of A and B, I'm just going to use arithmetic. I'm going to take A and add it to B. I'm going to take the absolute value of A minus B and add it to A plus B. And then I'm going to divide it by 2. And I claim that that gives you the maximum of A and B. Right? I'll let you puzzle this out to see and convince yourself that this is true. Right? If you want, you can come ask me about it and I'll draw you a picture and show you why it's true, mathematically. Right? Okay, to call the function, you import the header file in C. Right? So I import the header file, then I can call the function. Right? So in Java, it's sort of similar. It's not exactly the same. So Java has no functions. Right? Java has these things called methods instead. The closest analog to a C function is a public static method. Right? Everything's in a class, so it's a public static method that lives inside of a class. Right? So methods are basically functions, right? But they're defined inside of a class or this thing called an interface. Right? So if I want to make the corresponding function in Java, I create a class. Right? So I'm going to call that lecture2. Inside the class, I'm going to create max2. Right? Notice it's almost exactly the same. Right? There's your int, there's your max2, there's your int A and B. Right? Except you've got public and static sitting in front of it. The code inside is almost exactly the same as your C code. Right? It's A plus B. The absolute value method in Java is math.abs. Right? And everything else is the same. Right? So there's my definition of the max2 function. There is no prototyping, right? So there's no header file. Now, to call max2, right? If I'm inside of a different class and I want to use max2, right? And that class, oh, sorry. Yes. If I'm in a different class, I want to call the max2 method, right? Then you import the class containing the method that you want, right? So here I'm going to import lecture2. I'm going to show you this in a second in Eclipse, right? And it's going to look a little bit different, right? When you call the method, right, you have to use the class name in front of the method. So it's lecture2.max2 and then 5 and 3, right? So instead of just writing max2, 5, 3, you have to put the class name in front if you're calling a public static method. Right, so let me just show you that in Eclipse. Okay, so here I've got here's my lecture2 class. Right, now there's a bit of a difference here compared to the lecture slides. Lecture2 happens to be declared inside of something called a package. Right? So packages in Java are just a package in Java. The package mechanism in Java is Java's mechanism of organizing your source code into folders. Right? So somewhere on my computer there's a folder called lecture2. Right? Inside that folder there's the class containing the contents of lecture2. Right? So the class is called lecture2.java, which is right here in Eclipse. Right? So there's my class. You can see here, there's the lecture2 package. Right? There's my method defined inside the class. Right? Now, if I'm in some other package, so here I've got some other package, right? Some dot other dot package, right? And inside that package, I've got a class called test lecture2. Right? And here's where I'd like to call the max2 method from. Right? So to call the max2 method that lives in lecture2, I have to import the class little l lecture2 dot big L lecture2. Right? That's the package name that class is living in. Right? So import the class, call the method by using the name of the class in front of the method, and using a dot in between, right? Just like you would access a structure member in C. Right? So if you run this, you actually do get 5, which is good, right? That is the max of 5 and minus 3. Right? So importing in Java is analogous, well, it's similar to including a header file from C. What actually happens is actually different in the two languages, right? But it's the same basic idea. right? If I want to use something that's defined inside of another class, that's inside of a different package, I have to import that other class. Okay, so let's go back to lecture 2. Suppose I'm inside the lecture 2 class itself, right? Notice that test lecture 2, there's a main method, right? In lecture 2, there is no main method. So lecture 2 on its own is not a complete Java program. I can make it a complete Java program by adding a main method. Right? So I can do public static void main. Like that. Right? Now from inside the same class, I don't have to import the class. Right? I can just call max2. So for example, I can do int z max2, 1 and 5. That, right? And then I can do, oops, sorry. How does this work? There's a way to shortcut system.out. Isn't it? There it is. Okay. Z, like that. Oops, sorry. My control key is busted, which is why you often see weird things happening. Control S, come on. There we go. Oh, sorry, print line Z. Thank you. Okay, right? So with inside the same class, you don't have to import anything, right? If you're in the same package, you also don't have to import anything. So I'm going to grab test lecture 2. I'm going to make a copy of it, so Control C. I'm just going to paste it into this package, right? So now this is test lecture 2. It's now inside the lecture 2 package. Right? If I try to import the lecture 2 class, right, Eclipse says, it highlights it with a little light bulb, and it says, hey, you never actually have to use this thing here. Right? So you don't have to import a class if it's inside the same package. Right? So I'm inside the lecture 2 package. I'm inside of a different class. Right? I can access the public stuff in lecture 2 directly. Right? So here, this still works, right? I can still run it, I still get 5, right? You have to put the name lecture 2 in front because that's where the method lives, right? If you're inside the class itself, you don't have to write lecture 2 in front of the method, right? It knows that the method is inside the class. If you want to, you can. So you can write, oh, sorry. Control Z, you can write lecture 2 here, like that. Right? So if you want to write the class name in front of it, you can, and that works just fine. Okay, so later on, so in the lab this week, I'm going to explain to you how Java organizes its files into certain directories and things like that. And I'll show you how you find those directories on your computer so that you can submit your work after the lab. Okay. So that's it for that set of slides. So I'm now going to move to the next set of slides. If anybody has any questions, just interrupt me. Okay, so like in C, you should try to keep your code neatly formatted, right? And so there are different people think good formatting looks different, right? So good formatting looks different to certain people. Right? I always insert spaces around my operators, right? So it's always A space plus space B plus and so on and so on and so forth, right? A lot of people don't like the spaces in between. That's not such a big deal, right? Indentation, though, is more of a bigger deal to people who have to read your code, right? So as in C, indentation is used only for readability. The compiler doesn't actually care what your code looks like, right? You should try to make your code look like what you see on the lecture slides, but the compiler doesn't care, right? So I can go into here and I can delete like pretty much all of the spaces, right? So I can get rid of that line there. I can keep on going. I can drag this line up to the next line, right? I can even take its brace up to the next line. The compiler doesn't care, right? It looks awful, hard to read, right? Still runs, no problem. So indentation is not a fundamental part of the language, but it does make your code a lot easier to read. Right? Like in C, Java is a brace delimited language, right? So the braces define blocks, right? So the blocks can be nested, right? So I've got an outer block for the class in red, right? Inside that block, there's a block for the method body, right? Inside the method body, you might have other blocks if you have a for statement or an if statement, right? Braces are required here, right? Just like they are in C. For the time being, all of our classes are public, right? So that word there is what's called an access modifier. The public access modifier means that the class lecture 2 is visible to all other classes, right? That's all that it means. So every class can see the class lecture 2, and that just means that every class can use any of the public features inside of lecture 2, right? So unlike C, where everything is public by default, right, you can control the visibility of things in a Java program, right? So I can control the visibility of a Java class. Making it public means that anybody can see this class, right? Also, for the time being, all of our methods are public as well. That just means that any other class can also see the method max2. Right? Later on, we're going to see different uses, different access modifiers for the methods. And finally, there's this static word, which means something very different than what it means in C. Right? So a static method in Java is a method that is associated with the class. So static int max2 says that the method max2 belongs to the class lecture2, and when you call the method, you always use the class name in front of the method, right? So lecture2.max2. Right? If the keyword static is not here, right, that means that the method belongs to an object whose type is lecture2. So to call a non-static method, you need an object reference, you need a variable to call that method, right? And then use the variable name followed by a dot followed by the method name, right? We'll see those in a little bit, right? For now, though, everything is static for our purposes. Okay, so C, Java methods are basically C functions, right? They've got parameters. Right? So here the parameter list is int A, int B, right? It means exactly the same as what it means in C, right? Your first parameter has type int, your second parameter has type int. To call the method, you need something that can be converted to an int and something that can be converted to an int, right? The return value for a Java method is exactly the same as the return value for a C function, right? In both languages, you can only return one value, right? So max2 returns a value of type int, right? If you want a method that returns no value, then you use void, right? Just like in C. Right, so here's the main method, right? Main method in Java never returns a value, unlike C, which always returns an int, right? So the return type for main in Java is always void, right? If your method does not return a value, the void word has to be here. Okay, if your method says that it returns a value, there has to be a return statement, just like in C, right? So the return value, that value there, has to match the return type that your method says it returns, right? So whatever twice max2 divided by 2 is, it has to be an int, right? And in this case it is, right? Because twice max is an int, right? 2 is an int. You got an int divided by an int, so we know from earlier in the lecture that this value is always an int. And void methods have no return statement, although you can use an empty return statement if you want to end the method, right? So you can write return semicolon, right, like that, right? And that will end the method, right? So that is legal for a void method, just like in C, right? Okay, if statements, again, exactly the same in C and Java, right? So if you want the max of 3 values and you want to compute it in a sane way as opposed to max2, right, you just compare all the values A, B, and C. Right? If A is greater than or equal to B and A is greater than or equal to C, the result must be A, right? Here, the result must be B. Here, the result must be C, and then you can return the result at the end there, right? If you want to, the else part, just like in C, is optional, doesn't have to be there, right? So you can get rid of the else clause from here, right? Here, the result is C. So instead of having no value for the result up here, I can set the result to C, right? And then I can adjust the value if it happens to be A or B instead, right? So the else part is optional. The else if part is optional as well, everything's the same as in C, right? So your condition has to appear inside parentheses, right? The scoping of variables is almost the same as in C, right? So for the time being, it's exactly the same, right? So here's our max3 method. It has 3 parameters, right? The scope of A, B, and C is the body of the method max3, right? So anywhere between that brace and that brace, you can use the names A, B, and C, and they correspond to the values A, B, and C that were passed to the method. Right? The variable result is declared here, right? So the scope of result is anywhere from where it's declared to the end of the block in which it's declared in, right? So the end of the block in which it's declared in is here, so you can use result from this point on inside this method. Can't use it outside the method, right? So a common mistake you see from, well, hopefully not you guys, but certainly the computing science students is they'll write code that looks like this, right? So they'll say, well, I know that the result is A in this situation here, so I'm going to make a variable called result and set it to A. Right? Here they say, well, result's got to be B, so I'll make a variable called result, set it to B, and I'll try to return result here. Right? This doesn't work, right? The scope of this result is the block in which it's defined in. Right? So that's that block right there. So outside of this block, result does not exist. Right? Same is true for this result. Right? Its scope is the block in which it's defined in. Well, the point at which it's declared to the end of the block in which it's defined in. Right? So outside of this block, result doesn't exist. So result doesn't exist down here, and the compiler barfs. Right? You should also know this. So you can have more than one return statement in a method, right? But there can't be any code immediately after the return statement, right? So here, if I happen to know that the result is A, I can just return A, right? I don't have to set a variable to A. I can just return A, and away you go, right? You're not allowed to put any code here because this code's not reachable, right? A return statement ends the method, right? So if you ever reach this line of code here, the method stops. So no code allowed here. Right? Similarly here, if you know the result is B, you can just return B. Right? And similarly, if you get past the if statement, you know the result must be C, so you can just return C here. Right? And no code is allowed after that statement there. Right? This one might catch you. So, well, I know it caught some of your colleagues from last year. Right? So you might write the following piece of code. Right? So here's the exact same thing, right? Here I know the answer is A, so I return A, right? This else statement, else if statement, you know the answer is B, so you return B, right? And now you put in an extra else if statement, right? And you return C, right? The problem is if you actually type this into Eclipse, it'll complain. It'll say, hey, your method doesn't return a value, right? It's expecting there to be a return value somewhere down here, a return statement down here. Right? And the reason this happens is because the compiler is not smart enough to logically deduce that the answer must be one of A, B, or C. Right? It sees if some condition. Right? So as far as the compiler is concerned, this line of code may or may not run. Right? Then it sees else if some condition. Right? So as far as the compiler is concerned, this line of code may not run. And then finally it sees else if some condition. So again, this line of code, as far as the compiler is concerned, may not run. Even though mathematically, if that's not true and that's not true, that must be true, right? So mathematically, this must run, but your compiler is not a mathematician. So it doesn't know that that line of code must run, right? The correct answer here is to remove the else if statement, right? Either replace it with an else or remove it altogether. Okay, and or, double ampersand, double vertical bar, right? So and is the logical and operator, exactly like in C. Don't use the single and. It often works, but it means something. Oh wait, in Java does it work? It doesn't work in Java. In C it does work, but in Java it won't work. You need the double and if you want logical and. Right? Or is double vertical bar, right? And if you remember this, and has higher precedence than or. So if you write a somewhat complicated logical statement, you may have to use parentheses or you have to check that your precedence is in fact correct. So a year is a leap year if it's divisible by 400, right? It's not if it's divisible by 4. So if it's divisible by 400, it's a leap year, right? Otherwise, a year is a leap year if it's divisible by 4, but not evenly divisible by 100, right? So 2100 is not a leap year, right? Because it's not divisible by 400, right? It is divisible by 4, but it's also divisible by 100, so it's not a leap year, right? And so I can write a method, that determines whether that year is a leap year, right? By checking, is it divisible by 400, right? So here I'm using remainder, right? So is the year divided by 400, is its remainder 0, right? Or is the year after dividing by 4, the remainder 0, and the year after dividing by 100, the remainder is not 0, right? So is it divisible by 4 but not divisible by 100, right? Here and has higher precedence, so I know that that and that get evaluated first, and then the and happens, right? And then the or happens, right? If that's too confusing, just use brackets, right? Use parentheses to group everything together, right? So by writing in the parentheses, right, now you know that this statement is a separate statement from this statement here. Right. Okay. The result of this expression here, right, that's just true or false, right? So you don't actually need an if statement here, right? If this is all true, I want to return true, right? If it's false, I want to return false. So you can just return the result of the logical expression, right? You don't actually need an if statement here, right? Just return the result of all this. It's either true or false, and that happens to be the value that you want, right? So if you think you might continue programming in the future, especially if you think you might want to do this professionally, you're going to want to start thinking about writing your code this way instead of using the if statement, right? If you write code like this professionally, your manager will eventually say something to you, right? You should be writing it like that. And finally, just like in C, the exclamation mark is logical not, right? So if I want to know how many days are in February, I can use my leap year method to find out, is it a leap year, right? So if the year is not a leap year, there's 28 days in February, right? Otherwise, there's 29 days. Okay, what time is it? Oh, that's good, perfect. All right, so that's the end of the slide deck number 3. All right, so we'll start with slide deck number 4 in the next lecture. Those of you who have a lab today, I will see you in the lab this afternoon.